Hey everyone, welcome back to Mac Ninja. Today we are unboxing and testing 3 different brushless motors to help you find the perfect one for your drone projects. We have got the Sunny Sky X2212 980 kV motor, the 5010 750 kV motor and the 5010 360 kV disc brushless motor. Our goal is to measure their thrust across different prop sizes of 10, 11, 12, 13 and 14 inch propellers with varying pitches and see how they perform. This is a crucial step in drone design as choosing the right motor directly impacts your craft efficiency and power. The thrust chart for X2212 motor is provided by the manufacturer but only at idle conditions. I'll compare their data with actual test readings. For the disc motors, data is available only for 3S and 4S batteries. So I will test these on 6S setup since there is no chart available in that voltage. Now let's begin. Starting with the Sunny Sky motor, it comes with built-in bullet connector and mounting screws. Its price is around $16 or approximately 1500 INR. While that's on the higher side for a 980 kV motor, it claimed to be one of the most efficient motor as per its thrust chart. It's a clockwise rotation motor compatible with clockwise propellers only. The recommended prop is EOLO1038, which has a built-in nut and costs around $5, significantly pricier than the most common 1045 propeller. I've got the M6 nut to test the 1045 prop. I'll use the 3S 1300 mAh battery, 4S 1800 mAh battery and the 6S 4200 mAh battery. Has the test rig. This is the load cell for thrust measurement, XT60 connector for batteries and watt meter for readings. I'll be using the FSI6S transmitter and receiver for throttle control along with Hobbywing Skywalker 60 ampere ESC. Let's get everything set up and start testing. First I'll test with the 3S battery, then switch to the 4S. The temperature slightly increases but stays within the safe limit of 35 to 45 degrees Celsius. Results will be compared later with the thrust chart. Now let's test the 750 kV disc motor. This is an economical choice among disc motors recommended for up to prop size of 16 inches on a 2S to 6S batteries. I will test it on a wide range of propellers ranging from 10 inch to 14 inch made of ABS and fiberglass. I won't be able to test it on this 1245 glass fiber propeller because of smaller shaft diameter. I will test it on two parameters. First is 50% throttle and second is up to 10 amperes of current because beyond it the efficiency drops. Here is the last 350 kV motor. On side-by-side comparison, you can see the higher number of turns in 350 as compared to 750 because of less kV. Let's test it. I'll test it on two parameters. First is 50% throttle and the second is the 100% throttle. Now let's talk about the results. This Sunny Sky 980 kV motor, at 3S it produced around 289 grams of thrust at 2.6 ampere and 8.98 efficiency. On 4S it peaked at 947 grams at around 12.9 ampere with 6.24 efficiency. It is similar to its thrust chart. Now for the 750 kV motor, we got the maximum thrust of 998 grams using a 1238 propeller and the best efficiency of 5.33 with an 1150 propeller giving 714 grams of thrust. Now the last is 360 kV motor. It gave a maximum of 498 grams of thrust at 50% throttle using 1147 propeller and the maximum efficiency of 9.03 with a prop of 1145 but only around 245 grams of thrust, which is insufficient for most of the applications. Based on the test, you can choose the motor that best suits your project needs. The detailed results along with the thrust chart, the motor best buy link are in the description blog. If you have any question or need help selecting the right motor, then drop a comment below. So guys, if you have liked this video and found it informative, then please like, share and subscribe to my Mac Ninja YouTube channel. So thank you guys for watching it. I'll catch you later with the next project.